Okay guys, so there are two screencasts that I'm going to give you on reactions with acids and bases. And the first one I'm going to talk about goes right along with the review book, so I'm trying to go along with the review book. And it is an acid reacting with a metal. So what you need in order to figure out which acids react with metals is table J. The only side on table J that we care about though is the metal side, so we don't care about the non-metal side this time. Hopefully this reference table looks familiar to you because we have discussed it in the past. But when it comes to an acid, if you look through all of the metals here on down here, you should see something that doesn't look like a metal at all, and it's hydrogen. So even though there's an H2 there, it just basically means an acid. So any metal that is above H2 on this reference table, all of these guys will react with an acid. Sorry, they are more reactive than an acid. Anything below H2 will not react with an acid. So I just put together a couple of equations here just to show you. We've done this similarly, remember, because these are what type of reactions? Single replacement. So what we're looking at is we're looking at the hydrogen to be replaced by the metal. Now because, again, if you find Mg on table J, it's right here, and it's higher than H2, this reaction will happen. Okay, you need to know a little bit more about that as well. Whenever an acid, regardless of the acid, if it reacts with a metal, it always produces hydrogen gas. Hydrogen gas is diatomic and it looks like this. And you might be like, well, there's not two on the other side, but that doesn't matter because we're going to balance it at the end. Okay, the other thing is we're going to be making the remaining compounds or the remaining ions, and what's remaining, right, is going to be the Mg and the Cl. And we always write the positive ion first, which is Mg. And then remember this from the last lab we did. We need to look up the charges, and then we crisscross, and we end up with that. And then we can go ahead and balance it and put a 2 in front of that. The next one we'll take a look at is, this is sulfuric acid. So I just picked a whole bunch of acids just so you start to get familiar with what an acid is. And then we're looking at K. So we're comparing H on table J and K. So if you look on table J, you can see that K is up here and H is down here. So yes, this reaction will occur. And the products, like I said, is always going to be hydrogen gas. And there happens to be 2 on the left side, but it doesn't matter. And then whatever is remaining, which is going to be the KSO4, but again, we have to look up the charges of K, look up the charge of SO4, polyatomic, and then we write the formula. And then if we balance it, I think we just need a 2 here. Okay, so I would just pause this video and go ahead and see if you can figure out the third one and the fourth and the fifth one. Okay, so for this one, again, this reaction will occur because zinc is higher than H2 on table J. H2 is produced, as well as ZnNO3. Zn has a charge of +2, NO3 has a charge of -1, so we would write it like that. And then to balance it, we would just put a 2 in front of that. So I think that's balanced, yes. Okay, now Cu and CH3OOH, I put that weird acid on there, right? But it is an acid, and the one, the H really that we'd be looking at is that one. But because Cu is lower than H on table J, right, it's down here, this reaction won't happen. So no reaction. I'm just going to abbreviate RXN. Okay, and then here we have another metal with an acid, and again, because that metal is lower on table J, this is also going to be no reaction. So I'm going to give you a couple of practice equations later on for you to work on, but for now it's just the homework in the review book. Stay tuned for the next one, which is going to be neutralization reactions.